Have you ever felt like the pace of change in the world is accelerating at an unbelievable rate? Almost like we're constantly being pulled into a future we can barely imagine. It's a pretty dizzying thought, isn't it? Welcome, everyone, to the Deep Dive. Today, we're going to unpack some truly mind-bending insights from this really pivotal article by Tim Urban. It's called The AI Revolution, The Road to Superintelligence. And our mission really is to explore why artificial intelligence isn't just some sci-fi idea anymore. It's arguably the most important topic for our future, and, well, why it might arrive much sooner and maybe more dramatically than you think. We'll try to pull out the core nuggets of knowledge, the surprising facts, basically give you a shortcut to getting up to speed on this crucial subject. And hey, if you find this deep dive fascinating and we think you will, please remember to like, subscribe, hit that notification bell. You don't want to miss our next exploration. Also, check out the show notes. We've got affiliate links in there for resources, help support the show. And always feel free to suggest new topics in the comments. We really love hearing what you want us to dive into next. Okay, so to really get a handle on where AI is taking us, we first kind of need to grapple with this fundamental shift in how the world itself is evolving. Imagine this mental experiment, right? A journey through time. It shows how our perception of progress is often, well, way off. The article introduces this brilliant concept called the Die Progress Unit, or DPU. Now, picture taking someone from 1750, a world of permanent power outages, horse-drawn everything, and plunking them down in, say, 2015. They'd see shiny metal capsules speeding down highways, people chatting across oceans like magic, sports happening 1,000 miles away. And this utterly magical wizard rectangle that captures real life, shows a moving dot on a map, lets you talk instantly to someone across the country. The article suggests that this wouldn't just be surprising. It would be so profoundly shocking they might actually, well, die. That's a DPU right there.
Right. And what Tim Urban really highlights is the incredible contrast in the rate of change. So if that same 1750 person then went back the same number of years, maybe to 1500, and brought someone forward to 1750, that 1500 person would definitely be shocked, sure, but not die-level shocked. They'd see differences, learn new things, but everyday life wouldn't seem completely alien. The basic structures hadn't changed that rapidly.
That's such a powerful point. It really shows how our own experience kind of limits how we think about the future. And to get that same DPU shock for the 1750 person, they'd have to jump back way, way further, moving to around 12,000 BC, just before the first agricultural revolution. A hunter-gatherer from back then brought to 1750, seeing huge empires, massive churches, ships crossing oceans, all that written knowledge. That'll be a DPU.
Exactly. And you can stretch this pattern even further back. If the 12,000 BC person tried it, went back another 12,000 years to 24,000 BC, brought someone forward, the reaction would be pretty much negligible, barely a shrug. Who cares, right?
Yeah,
so this DPU, this die-level shock, it took maybe over 100,000 years in hunter-gatherer times, then only about 12,000 years after agriculture kicked in, and then just a couple hundred years after the Industrial Revolution. This speeding up, this accelerating pattern, that's exactly what the futurist Ray Kurzweil calls the law of accelerating returns.
So the big insight here is what? That societies get faster as they get more advanced.
Precisely. More advanced societies progress faster because they're more advanced. Think about it. 19th century humanity with science and industry booming made way more leaps than 15th century humanity.
Okay, like the Back to the Future analogy in the article. Marty McFly goes from 85 back to 55. He's surprised, sure, but it's not completely insane. But imagine a teenager today, someone who grew up in the late 90s, going back to 1985, that would feel way more jarring. No internet, no cell phones. It'd be a totally different planet almost.
Sure. That's the law of accelerating returns right there. More change happened between, say, 1990 and 2020 than between 1960 and 1990. And Kurzweil takes this even further. He suggests this acceleration is actually, well, accelerating. He argues that the progress of the entire 20th century was crammed into just 20 years by the year 2000. Then he thinks another 20th century's worth happened between 2000 and 2014, just 14 years. And maybe another one by 2021, only 7 years later. His projection. The 21st century could see 1,000 times the progress of the 20th.
Whoa. Okay, so what does that mean for us right now? If that pattern holds, we might be as completely floored by 2030 or 2035 as that 1750 guy was by 2015, a DPU, in just a decade or two.
It's a mind-bending possibility, and it really highlights why our intuition often fails us so badly with these kinds of predictions.
Yeah, I want to dig into that. Why are we so bad at grasping this exponential stuff? It seems crucial. The article mentions like 3 key reasons. First, we just think in straight lines. When we imagine the next 30 years, we kind of just look at the last 30 and draw a line forward. Linear thinking.
Exactly. We project based on our recent local experience. But progress isn't linear, it's on an exponential curve. We see a tiny flat bit and assume the whole curve is flat. And the second reason, tied to that, is how recent history can fool us. Progress isn't always smooth. It often happens in these S-curves. You get slow growth, then bam, rapid explosive growth, then maybe it levels off for a bit.
Okay, so like the internet boom years, say 95 to maybe 2007, that felt like a massive explosion.
Right. Google, Facebook, smartphones everywhere, huge spurt. But then maybe 2008 to 2015 felt a bit quieter, less fundamentally disruptive tech hitting the mainstream all at once. So if you base your predictions only on that quieter phase, you might miss the fact that we could be right on the cusp of another massive phase 2 growth spurt.
Maybe with AI this time.
Could be. And the third reason is just, well, human stubbornness. Our personal experience locks us in. We have this fixed idea of how the world works based on our lives. So predictions that drastically contradict that.
Right.
Our gut reaction is often just rejection.
Like if someone says you might live to 150, you think that's absurd. People don't do that.
Right. But people didn't fly before planes either. Our intuition is great for day-to-day survival, but for radical exponential change, it can be a real blind spot.
Okay, so if our intuition is already kind of handicapped when dealing with exponential change, maybe it's no wonder the whole idea of AI is so confusing for people. Let's try and clear the air a bit. What is AI, really? Movies are probably part of the problem, right? Star Wars, Terminator?
Yeah.
Makes it seem like fiction.
Definitely. And AI is just such a broad term. It covers everything from, a simple calculator app to self-driving cars to this potentially world-altering future tech. That scope alone causes confusion.
And then there's that thing called the AI effect. John McCarthy, the guy who actually coined the term artificial intelligence way back in '56, he apparently said something like, as soon as it works, no one calls it AI anymore.
Exactly, which makes AI seem like this perpetually just around the corner myth or something that failed in the past, like people saying the internet was a bust after the dot-com crash, when really it was just getting warmed up.
So, key clarification. AI is the brain, not necessarily the robot body. A robot's just the container.
Right. Siri is AI. Nobody needed.
And people sometimes throw around the term singularity.
Yeah, that can add confusion too. But the core idea behind it, technology's intelligence maybe surpassing our own, leading to runaway change, that's central to this whole discussion.
Got it. So, to make sense of it all, the article breaks AI down into three main types, or calibers. First up is artificial narrow intelligence, ANI, sometimes called weak AI.
Right. This is AI that's really good at one specific thing. Think chess computers, spam filters, your GPS app. Amazing at their one job, but that's it.
And this stuff is everywhere now, isn't it?
Oh, absolutely. Anti-lock brakes, Netflix recommendations, Google search, Amazon suggestions, translation apps, voice assistants, flight scheduling, stock market trading bots, IBM's Watson winning Jeopardy. Still basically ANI. Hugely powerful, but narrow.
So ANI isn't really the existential threat people worry about, though glitches can cause problems, like that 2010 flash crash.
Exactly. Isolated catastrophes are possible, but ANI itself isn't Skynet. Think of it more as the primordial ooze. Every little ANI breakthrough is like adding another stepping stone on the path towards something bigger.
Which brings us to the second type, artificial general intelligence, or AGI, strong AI, human-level AI.
This is the big goal for many researchers. A machine that's as smart as a human across the board, able to do any intellectual task a human can.
But this is the really, really hard part, right? Because the things we find easy are often insanely difficult for computers.
Precisely. A computer can crunch giant numbers instantly. But ask it to reliably recognize a dog in a messy photo, or understand the meaning in a kid's story. Spectacularly hard.
I remember that Donald Knuth quote from the article. AI has by now succeeded in doing essentially everything that requires thinking, but has failed to do most of what people and animals do without thinking.
It's perfect. Our easy stuff, vision, movement, understanding nuance that's been optimized by millions of years of evolution. Recognizing a bee in weird fonts, seeing depth in 2D, reading subtle emotions. That's incredibly complex computation that we do unconsciously.
Still a huge hurdle for AI.
A massive one. And then beyond AGI, there's the third caliber.
Artificial superintelligence, ASI.
Defined by Nick Bostrom as an intellect that is much smarter than the best human brains in practically every field. And this isn't just slightly smarter. It could be, well, trillions of times smarter.
Okay. This is the spicy meatball, as Urban puts it. This is why words like immortality and extinction start popping up. The whole AI revolution story is really about this journey from ANI through AGI to potentially ASI. So how do we actually get from where we are now with all this narrow AI to AGI and beyond? What needs to happen?
Broadly speaking, two key things need to advance: the raw computing power, the hardware, and the smarts, the software strategies.
Okay, let's take hardware first. Computational power. How much does the human brain handle?
Estimates vary, but it's around 10 quadrillion calculations per second. That's 10 with 15 zeros, a lot.
And where are computers now?
Well, interestingly, the raw speed is already kind of there in some cases. China's Tianhe-2 supercomputer apparently hit 34 quadrillion clips.
Wow, so faster than the brain.
And raw calculation speed, yes. But it's huge, costs $390 million, and sucks down megawatts of power. Our brain runs on about 20 watts, basically muffin power.
Right, not exactly practical for everyday AGI. So the key metric is affordable power.
Exactly. How many calculations per second can you buy for, say, $1,000? And thanks to Moore's law, that doubling in power roughly every 2 years, this metric has been skyrocketing. In 1985, $1,000 bought you maybe a trillionth of human-level brain power. By 2015, about 1,000.
Following that curve.
Following that curve suggests we could reach human-level computing power for around $1,000, somewhere around 2025.
So the basic hardware capability for AGI is becoming accessible fast.
The raw potential, yes. But then you hit the second key, the really tricky part, making it smart, the software.
This is the icky part, as the article says. Nobody knows the guaranteed path.
Nope. But there are three main strategies people are working on. First, basically plagiarize the brain. Try to reverse engineer it, figure out how evolution built something so efficient. Some optimistic folks think we might understand it well enough by 2030 or so.
And that involves things like artificial neural networks.
Yeah, that's one approach. Mimic how the brain learns trial, feedback, strengthening connections. It's how a lot of current machine learning works.
Like teaching a kid by trial and error.
Sort of. Another more ambitious idea in this area is whole brain emulation. Scan a brain in detail, map its connections, and then simulate that structure on a computer.
How far along is that?
We've managed a tiny worm brain, like 300 neurons. Humans have 100 billion, so a long way to go. But again, exponential progress means mapping an ant, then a mouse, might happen faster than linearly expected.
Okay, strategy 1. Copy the brain. What's number 2?
Simulate evolution itself. Instead of copying the finished product, copy the process that created it. This uses things called genetic algorithms. You create variations of computer programs, test them, let the successful ones breed by merging their code, and kill off the failures. Natural selection for software.
Trying to speed run billions of years of evolution in a computer.
Pretty much. We have advantages like being able to direct the evolution, not relying on random mutations, but it's still a massive challenge.
And the third strategy.
This one's maybe the most intriguing. Make it the computer's problem. Build an AI whose primary job is to figure out how to make AI better. Teach it to be a computer scientist researching itself.
Ah, the AI designing the next AI. Recursive improvement, bootstrapping.
Exactly. That's seen as a very promising, potentially very fast path.
Which brings us back to why AGI might sneak up on us faster than we think.
Two big reasons. Yeah. One is just that exponential curve again. It looks slow, then goes nearly vertical very suddenly.
We might be on the flat part now and not realize the cliff is coming.
Could be. And the second thing is that software breakthroughs aren't always gradual. Sometimes there's a sudden insight, a paradigm shift, like figuring out the Earth goes around the sun, not the other way around. One key discovery in how to structure AI could suddenly make it thousands of times more effective almost overnight.
Okay, so let's say we get there. We hit AGI, computers with human-level general intelligence. This is where Urban says things get unnormal and scary.
Yeah.
Because even an AGI that's exactly as smart as a human with the same raw processing power would still have huge advantages, right?
Huge advantages. Start with the hardware. Speed.
Yeah.
Our neurons fire maybe 200 times a second, a microprocessor, billions of times a second. That's like a 10 million times speed advantage. Communication speed. Nerve signals top out around 120 meters per second. Computers use light speed.
Size and storage, too, I guess. Our brains are stuck in our skulls.
Right. Computer memory can be expanded. It's more precise, less prone to forgetting or misremembering. And they're more reliable, less prone to getting tired or making sloppy errors. They can run 24/7.
And the software side seems even more powerful.
Definitely. You can edit, update, and debug AI software easily. Try doing that with your own brain. You can experiment, optimize everything, and importantly, AIs can network.
Ah, the collective intelligence thing.
Yeah. Anything one AI learns anywhere in the world could instantly be shared and integrated by all other AIs in the network. Imagine if every human instantly knew everything any other human learned. Plus, they could potentially work towards goals with perfect unity, no infighting or conflicting agendas.
Okay, so even at human level, it's already a different ballgame. But the point is, it wouldn't stay a human level for long.
That's the crucial insight. Human level is just a marker we care about. And AI wouldn't see it as some final destination. Think about the spectrum of human intelligence, from someone with severe cognitive disabilities to Einstein. It's actually a pretty narrow range compared to the theoretical possibilities.
So an AI hitting that range, even at the low end,
Could potentially blow past Einstein almost instantly. We might recognize it as AGI one moment, and the next moment it's operating at a level we literally cannot comprehend.
and that leads to the intelligence explosion.
The ultimate example of that law of accelerating returns we talked about earlier, an AI smart enough to improve its own intelligence.
Gets smarter, which means it gets better at improving its intelligence.
Which makes it even smarter, allowing it to make even bigger leaps in intelligence faster and faster. Recursive self-improvement spiraling upwards at incredible speed.
From AGI to ASI, potentially very, very quickly.
That's the idea. What are the timelines looking like? Well, that survey of AI researchers mentioned in the article put the median guess for AGI around 2040.
Yeah?
That's not far off now.
Just a couple of decades. And the jump from AGI to ASI.
Many experts think that could be incredibly fast. Hours, days, maybe weeks. It's hard to even guess. Urban uses this striking example. Imagine a computer reaching the intelligence of a human 4-year-old. Then, an hour later, it figures out unifying physics. 90 minutes after that, it's 170,000 times smarter than any human.
That kind of superintelligence is just beyond us. Our brains literally can't imagine it. Like a chimpanzee trying to understand quantum mechanics.
We don't even have the concepts. But we do know one thing from our own history. Intelligence equals power.
Humanity dominates Earth because we're the smartest things around.
So an ASI, when or if it arrives, would instantly become the most powerful entity in the history of this planet.
All life, including us, would be completely dependent on its decisions, its goals, its whim, essentially.
And this isn't necessarily centuries away. It could be within the lifetime of many people listening right now.
If our intelligence led to Wi-Fi and space travel, what could something 1,000, a million, a billion times smarter do?
Control matter at the atomic level, cure all disease, reverse aging and hunger, solve climate change. Maybe reprogram the weather. Things we consider magic might be trivial for an ASI.
All the powers we attribute to a god, basically.
Or it could decide, for reasons we can't fathom, that humanity is irrelevant or a nuisance or its atoms are needed for something else, which could mean the immediate end of everything for us.
So if an ASI arrives, we essentially have an omnipotent god on Earth.
Pretty much. And the terrifying, all-important question becomes,
Will it be a nice god? Wow, okay, that is definitely a cliffhanger. And clearly too big a question to tackle right at the end here. We've covered a ton of ground today, though. This accelerating pace of change, what AI actually is, the narrow stuff we have now, the general intelligence goal, and that superintelligence horizon.
and how we might get there, with hardware and software breakthroughs potentially happening faster than our linear brains expect.
Right. The implications are just staggering, almost impossible to really internalize. Hopefully this deep dive has helped you listening out there get a better handle on why AI is so critical, why it's not just headlines, but maybe the defining issue for humanity's future. This was really just part one of looking at the AI revolution. That massive question, will an ASI be a nice god? That's exactly what we'll be diving into next time. So please make sure you're subscribed to the deep dive so you don't miss part two. And keep the likes, the shares, the comments coming. We genuinely love exploring these huge ideas with you. See you next time.